Welcome all. Really excited to invite you to this event today, put on by Aurora Digital, TLA Smart Cities, and Tech UK. So really grateful for their support for this event. As I'm sure you saw when you registered, we've got a stellar lineup of speakers for you today, who hopefully will be able to provide you with a really good understanding of the capabilities with 5G, particularly around sort of video analytics and computer vision. Hopefully you learn a lot. Be great if we can be interactive. Please ask any questions as we go through. I believe there's going to be a poll at some stage during the event as well, so please participate in that. You've got a very, very senior level of speakers today, so hopefully that's an opportunity for you to ask anything that you want. Just as a background, Aurora Digital, what we do, if you've never heard of us, is we support and showcase great tech. I mean, that's kind of what we're about, and that's why we work with people like Tech UK and TLA Smart Cities and so on. And so we run a bunch of events like this. Today, the session is moderated by the wonderful Richard Foggy from KTN, the Knowledge Transfer Network. Far more knowledgeable about this area than I am. I hope you really enjoy the event, and I would really like to hear your feedback afterwards. And with that, Richard, I will hand over to you.
Thank you, Sandy. Welcome everybody to the wonderful world of MEC. Mobile edge computing, as panelists, attendees have already picked up, it is strictly, according to EXE, multi-access edge computing. It's an example of the flexibility of architecting that 5G allows, so that you can develop solutions that are specific to the application that you're looking at. Sandeep's correct. We've got a stellar lineup, self-excluded. I'm Foggy from UK 5G, in addition to wearing a KTN hat. So moving swiftly on, Danny Kelly, could you tell us whether this MEC thingy, what does it enable growth or anything? Or
it's been rumored to, Richard. Yes, I believe so. Yes, I think Richard, 5G and MEC, it poses a great opportunity for us to really transform industry. But I think if we just talk about 5G and MEC on their own, I think we miss the other key part, and that of course is the applications that take advantage of that. So the growth opportunities now is not because the network operators have built great 5G networks that bring, of course, speed and latency and security and all the great benefits of 5G. But the reality is the growth opportunities is born when we bring together 5G and MEC, as you say, and then those great applications that take advantage of those attributes across the edge compute and across the 5G networks. So when we combine all of that together, we're in a space where we can now really begin to transform industry. But the reality is, and it's very different where we are today, I think in the past, we've all went off there and built products and services and tried to sell them to customers and took them on a journey of transformation. Today, 5G and MEC and applications really requires an ecosystem of partners to do that. We don't know one supplier has all of the answers, and therefore we've got to work together with our customers to understand what outcome are we trying to achieve, and then work backwards from that outcome. When we understand the transformational outcome, we can understand, okay, so what's the network configuration for that? What's the edge compute configuration for that, or the MEC configuration? And what's that secret sauce? What is the application that really brings that to life? So when we bring together this triage of applications, edge compute, and 5G networks, we really unlock the true potential of 5G.
Indeedy, and I'm given to understand that the thing with 5G and particularly with MEC is the massive volumes of data that can be shuffled around, cut, sliced, discarded, so you keep the good stuff. And the sort of devices that we're looking at, UHD video. Is it typically those very heavy bandwidth applications? Is that where we're going to see MEC deployed?
Yes, it's a primary use case for MEC. So that data is expensive to transport across the network. So that MEC really brings the compute part to the customer. So it's no longer about the cloud. The cloud was once king. Everything was in the cloud, but now actually the cloud's no longer king. We need to bring all of that compute that exists in the cloud right down to the customer site, or at least to the edge of the network, so that we can compilate that AI and compilate that video analytics, right at the customer site. So that's a brilliant AI, and video analytics is a great use case of MEC, whereby we can take the attributes of speed and bandwidth and capacity that 5G brings, but it's only half the story. Where do we process all of that information, all of that hungry data? And it's at the edge. So this is where MEC plays its part, and of course video analytics is a super use case for that.
Okay, so it's pulling the cloud down to ground level. I don't know, fog computing was a phrase that was bandied about. Is this fog computing made real?
Yeah, we're getting into that space, right? So I think it is only one of the use cases, of course, that we can leverage for MEC. It's a great use case, but I think every industry, when we think about what we're doing, whether it's robotics, autonomous vehicles, all of these things have a computational requirement that needs to happen close to the customer, close to the site, and close to the edge. So there's lots of use cases that we'll see all have these same attributes, which is where do we compute that information. And MEC gives us now the ability to really transform industry around, and whether it's transport, logistics, healthcare, manufacturing, you name it. We just think about, okay, what is the outcome we want to achieve, and how do we process that on the 5G network, and actually where does that data live? Is it at the edge of the network, or is it the customer site?
Thank you, sir. Indeed. And a good nod to applications there. Speaking of applications, smart cities. Now, there's an awful lot of data. There's an awful lot of people. There's an awful lot of useful stuff probably to be had if you can get that right. Paul Armstrong, can I move to you, sir? And could you give us some observations around using video and AI in a smart cities context?
Yeah, so if we think of 5G and MEC, I think the three things that lots of people talk about that it brings to a place is kind of speed and bandwidth, that latency of response, and the ability to deploy really dense deployments of applications and sensors. But I think there's also a really important part in there on the architecture of 5G actually brings together this merger of the fiber world, the Wi-Fi world, and the cellular world to make sure that everything's always connected as it moves around a city. But I think the kind of the $1 million question for everyone is always, so what? Like, what does that mean? And I suppose when we talk about what that means for a smart city, so connectivity is at the heart of everything that we do as a smart city, and our ability to crunch large volumes of data is what underpins us being a smart city. And actually MEC allows us to move from, I think, what we historically called a smart city, but if really we're honest, it was more a monitoring city. So we got really static measurements about how full a bin was, for instance, to really a city that moves truly to smart, a city that's dynamic and responsive to the needs that are there right now. And I think that's where we're seeing a huge shift over this move towards higher fidelity sensing, more data, the use of video, and actually how we start to push some of that data back to citizens, or how we push that data back to industry around the city so that they can respond to what's happening in the city as well.
Indeed. Do you have some slides you could share with us?
I do. I've got a couple of examples of just some of the things that as a city we use edge computing for, and the types of analytics that we can do on the data. I think it's fair to say, if you asked me probably even 2 years ago, if you thought that as a city we would be doing computing on iPhones in cars as they move around the city, or on the top of a car park, it would be my worst nightmare, and I wouldn't have ever believed you that we would do those things. But I've just got a couple of examples to show that those are actually real and those are things that are happening now. So I will just share these. So the first example is a project called How Busy is Toon? So this was funded by MHCLG, and this was all about how does a city recover, and how does a smart city recover from the COVID pandemic. So what you should be able to see there in the corner is there's a little video that we run on our CCTV, and it gives real live time information about how people are moving around the city. And we use that, so we used it in our COVID response. So the Director of Public Health could give people real time and real data backed evidence of how people were socially distancing around town, how people were returning to town. And also we use these things to publish on a website. So before anyone came into town, they could make informed choices about actually whether they wanted to come in, whether they could socially distance safe when they chose to do so. So again, that was just, we had an existing CCTV estate, but being able to compute at the edge allowed us to run other AI models across our CCTV estate that would give us huge amounts of more data than we'd ever had on the past. And the next one is a program called Detector. So this is something that we are spinning out of Newcastle University. So this is using an iPhone within vehicles that go around the city. So this is again using edge computing for video AI. It goes around and it real-time maps all of the assets in the city. So you can see there are lots of pretty dots and colors as it picks things up as it goes around. And this underpins a lot of our work around digital twins. And again, that's edge computing in the car, backed up by connectivity that allows us to back all that data off. And again, the kind of move is, in the past, this was done with probably 50 grand's worth of kit in a Google car. And actually the network is starting to allow us to do those types of things with off-the-shelf hardware now. So it's hugely cost effective, and we're starting to see lots of examples like that coming in cities. And I think that's where a lot of the examples that you'll see in cities come up. So there'll be a lot around of those dynamic use cases. So things like, how do we manage advanced logistics? How do we manage the road networks? Things like that, things where we can see data and we can make changes that change the environment. And I think that's where I see the real big use cases for edge computing and 5G in cities.
Thank you kindly, sir. Indeed, it's interesting, the use of sort of COTS technology there. How easy do you think it's going to be to get the 5G infrastructure out there? Piece of cake, pulling teeth?
As with everything digital infrastructure, I think that'll depend where you are in the country. And sadly, we do find that these things are always easier to deploy in dense urban environments. I think the reality is networks cost a lot to build, and it would be very easy for me to say, well, I want connectivity everywhere and I want someone else to pay for it. I think where industry and cities and the telecoms market can work together is starting to stack up some of these business cases, so that actually in a rural environment, we're not just talking about, well, I want you to deploy 5G because it gives my residents access to employment opportunities, education opportunities, and healthcare opportunities, but also it'll underpin advanced logistics, it'll underpin future tourism and a digital offer. It will underpin how we do logistics in that place with autonomous vehicles. And kind of as we stack up all of these, I think that's when we start to really see the business case drive down that value, that kind of cost to deploy against value for some of these things right across the country.
Oh, indeed. So an aggregation of applications, but that will come up with a value proposition that justifies it.
Yeah, and I think the kind of, as we look at the technology for 5G, the move towards software orchestration, so the network can be responsive to lots of different use cases and be optimized for lots of different use cases and respond to what's happening around it. I think that really suits this model of lots of tenants on a network, using it for lots of different things that have varying requirements throughout the day or throughout the month or throughout the year.
Thanks, sir. Danny, you got your hand up.
Yeah, very politely using it. And I just wanted to come in on the deployment of the 5G and the network 5G deployment. We all absolutely have a responsibility to ensure that as ubiquitous as possible and as quickly as possible. But actually in the enterprise space, 5G is truly ubiquitous today, so we can bring, of course, 5G networks to any business, to any premise, to anywhere. And there's lots of different ways we can skin a cat, Richard. It's not all about mobile private networks. It could be an in-building 5G coverage scheme, which doesn't cost the earth, but it allows true transformation. So it really just comes down to what is that application that we're attempting to enable, and then backwards from that we can work out what is the network architecture, how do we deploy that for our customers. Now in the public 5G space, of course, it's about how do we get that public 5G network rolled out for consumers to enjoy it, for businesses to take advantage of the public 5G, but actually to get that real security, low latency bandwidth requirement for certain applications, including video analytics, then we've got to be looking at a dedicated scheme. So how do we create that dedicated scheme? And the answer is today we can bring 5G anywhere, and that's true of all of the operators. We all have the ability to serve all of our customers across the whole country. So it's a great time to begin that transformation conversation for a right across industry. It is first and foremost an enterprise play.
Thank you. Yeah, good observation. I've got to say 5G isn't a Jan tomorrow sort of offer. You're absolutely right. There's great examples, and it doesn't have to be mass geo inside a shed doing very funky things very fast. That goes on. Yeah, indeed. Hafsa, indeed, from a Highways England perspective, now the use of video, I'd have thought is key to your operations. What are you doing with? What's the potential for 5G MEC and AI here?
Yeah, so a little bit of background on me. So I'm with KPMG, and I work with public sector on their digital data and technology strategy and transformation projects with a focus on mobility. So currently working with Highways England, as you mentioned. And we've done loads of work in the past just looking at the economic benefit and value of connectivity. So coming at it from a mobility perspective, we've seen numbers so ranging from £50 billion to £75 billion of economic value of cabs by 2030. We also see research suggesting, traffic delays reduction of 10% by the introduction of 5G networks. So given all of that news, Highways England has been working on developing their vision for digital roads, which is essentially looking at how they can harness connectivity in all of their operations. So starting right from construction to operations and how they deliver information to customers. And connectivity and 5G and video analytics actually plays a role in all of these three pillars. Starting from construction, biggest thing on a construction site is safety. So they are looking at how they can make sure that in the next 5 to 10 years, all of the new major schemes coming up can be connected, and starting to look at how video analytics can be used to make sure that there's enhanced safety on site. Going into operations, massive implications for traffic management, starting from actually just improving how the signals are set by dynamically monitoring the flow of traffic. Going to actually, if there's an incident, being able to spot a stopped car in a live lane. So there's a lot of trials happening in that space. Going one step beyond that actually is using 5G connectivity and multi-edge computing with video analytics is to spot the incident before it happens. So that's when you start looking at the behaviors of the drivers and start analyzing dangerous behaviors and stop an incident from happening. Then moving on to the customer space and sort of providing them information, there's a big push to understand how in-vehicle communication could work. So essentially moving towards an ambition of having naked roads by sort of 2050, where you may not need that much roadside furniture and infrastructure because you're able to communicate directly with the customer in their car. So the opportunities and sort of opportunities to grow and opportunities to be more efficient are massive for a business like Highways England. And they're looking at that. thinking about other public sector organizations, as Paul mentioned, loads of opportunities for cities as well. And we're seeing that cities are interested in understanding what 5G could do for them. So mobility and transport is always a big use case that everyone gets excited about, because there's a lot happening in that space already and it's easy to understand. Other use cases that we see people get really excited about is healthcare, especially when it comes to social care. Councils spend a large amount of their operational expenditure on social care, and being able to use video analytics in that kind of sort of scenario, again, could benefit not only the council in terms of, you know, the finances, but also our customers and citizens. So I think in sort of very quick summary, loads of exciting opportunities for growth because of this particular technology.
Thank you kindly. Wow, and it'll cure your asthma too. Well, but literally, in particular. Indeed, I know some great work going on with its application in social care, looking after vulnerables. Thanks very much indeed. And now, sort of a bit of a segue, because he's going to cover sort of some of the architectures and a sort of a ports example. Neil, could I introduce you, sir, and have your observations on the application spaces? And I think you do have some Port Authority digital twin exemplars up your sleeve.
Yeah, I mean, we've got a huge amount of work going on in service creation, and I think, you know, Dean on the Q&A is asking, you know, is how relevant is MEC to new services, and I think it's a good question. I think there's elements of it that help us. There's elements that we've already got. There's new things that you know, we haven't even considered. Or we've given up because it was too hard. And I think there are, you know, bringing more compute closer to people will always help think, you know, will always help people be creative, and always allow you to try things that, you know, 20 years ago, an old fogey like me would have said, nah, you'll never make that work. Well, maybe now we will. So I think it's always good to experiment. But I think if you look at it from an operator point of view, you know, we're out there building connectivity all over the country, in fact, all over the world through BT Global. And the stark reality is that we need to do more than just connectivity. So we're working in healthcare. We're trialing a huge number of new healthcare services. It's all about, you know, through COVID, one of the things I think has really been spotlighted and probably needs to be even more work done on is the kind of elderly and infirm who are maybe home alone. And, you know, mobile edge compute helps us, or multi-axis compute helps us with managing the scale and the complexity of that. Is there any, you know, brilliant new discovery in that? Probably not, but the scalability of it and the reliability of it, for sure, it is helping us. A few other use cases that we're using 5G for, outside broadcast through BT Sport. You know, we've done a number of outside broadcasts using 5G, particularly through this COVID period, where we've had our, you know, our commentators and our opinion people, what do they call it? There's a name for them, pundits, all over the place because of COVID, and 5G's helped us connect them and do some interesting things with video and virtual reality that would have been difficult. Again, edge compute plays a huge part of that. We have a model of a, you know, a big 18-wheeler lorry with compute on the back that we drive to a stadium, plug in, and allow people in the stadium to do, you know, some fantastic things. COVID's put that on hold because we unfortunately can't get a lot of people into the stadium, but hopefully that's about to change. And then yeah, you talked about digital twins. So, and I think this is really important for the UK. And I think the stuff that Paul showed was super exciting from my point of view, which is how do, you know, in a world where the UK is a knowledge economy, being able to build a digital twin for you to test things, program things, discover things, examine things in a way that's safe. You're not actually doing it in real time. You can use technologies like system dynamics to, perhaps create a flight simulator of a city or of a manufacturing plant, or as McLaren are down the road from where I live in Woking on their actual Formula One car. So, and then use the massive compute power that we've got in Edge to do some really quick processing that, yeah, you could argue do that in the cloud, but in some respects, if you're rotating a model, you want that, snappiness of reaction as you do it, an instant kind of response to the services, and then if you're building a product, you build a digital twin of a product, perhaps you've got a 3D printer at home, you can just press a button and print a prototype. And again, through COVID, lots of 3D printing done on stuff to help with face masks and other stuff that, had we had more edge compute, had we had more of this deployed already, would we have actually got even more? I'd like to think that we would have done. The other thing we're using, two other areas we're using edge compute for. One, believe it or not, I have to say I was kind of surprised by this when my team came to tell me about it, which is we're using edge compute to really, and I think linked to what Hafsa was saying, to really plot routes much better than we've ever done before. Sure, we've got GPS, sure we've got Waze, we all love it, but actually when you start to think about the number of journeys that happen every day that are almost predictable to like 90%, you put them into a big platform and say, okay, 90% of the traffic tomorrow we could predict. In that case, why don't we predict a space for them to travel effectively in? We have a pilot running with Ipswich Council in Suffolk around how we plan and rotate traffic through their city in a way that's super efficient and, takes a lot of congestion and all the negative stuff that goes with congestion out. And then finally, in ports and in manufacturing, and again, this is related to video, we've done a few use cases where, you've seen what happened in Suez and all the backlog of shipping containers, and in an increasingly, in a world where the supply chain is increasingly easily disrupted, or there's so much demand that it's keeping supply chains moving is crucially important. Apart from the shipping time, the longest part of the journey for a product is off the ship onto a port and then into your hands. So we've done a huge amount of work where in Belfast, where we're able to help them get a lot more telemetry around what ships are where, what cargo's on them, what's the weight, what's the dimensions, where's the lorry coming to pick it up, and just bringing all those things together so that it's just a much more smoother process, and you can start to automate it. Now, there's a lot of health and safety concerns there because you drop one of these containers and it could be bad, but again, by building out a private network that Danny was talking about, we can really get to an incredible level of fidelity with sensors around what's where and how it affects. And then finally linked to that in manufacturing. So, the UK is a phenomenal engineering country. If you want something engineered well, you get on a plane, you come to London, you come to the UK and we build it for you. And I think 5G has got a phenomenal part to play on that, whereby if you are building something, you want assurance on that build. So imagine you put in, imagine that the factory of the future has a sphere of cameras where every step in the manufacturing process is recorded and certified automatically. So you're, Rolls-Royce and you're building an engine for an airplane, you want to know that was built right. And if you have a problem, you want to be able to deconstruct it so that you can improve it. Again, edge compute is allowing us to put that level of video capability in in a way that's scalable, so that as that engine comes together, or as that product comes together, you can see every single detail about it, and then go back and even do it serial number by serial number if you so desire, and really understand what went right, or where are there opportunities for improvement, or are we 100% sure this engine was built because we saw this weird telemetry. And again, linking the in-flight telemetry of the engine, where there's now millions of sensors, back to that production line, so that they can understand, what they could tweak, what they could change, what they could do better, is fantastic. And if you think about, again, food production, imagine expanding that into food production and farms and kind of food production companies, and getting huge amounts of benefits and ultimately more efficiency. If we were as a global world, if we were able to improve our efficiency by 2 or 3%, that is massive. And each one of these little use cases that we're all talking about moves that dial. And we as telcos want to be a bigger part of that journey, because frankly, if we want to continue investing in the infrastructure, someone's got to pay for it. And right now, that's on connectivity, we're going to run out of road on their ability to fund and build the infrastructure that these use cases need.
Thank you kindly, Neil. Yeah, some good observations in there. Righto, moving on. Come data from Tech Mahindra, large system integrator, indeed, well versed in these enterprise solutions that Danny has referred to. Could you share your screen and tell us a little bit about what you've been up to in the AI space?
Yeah, so Richard, thank you. What happens in the whole system is that, although we have seen that there are a lot of use cases which all of us are discussing, right? So these kind of use cases are actually driving the whole scenario, right? May it be your digital operation, production, safety, wherever, across industry segment, there are video analytics, correct? And we see that this kind of solutions, analytical solutions, day in and day out, it is increasing. With the new technological innovations, we are getting more and more of the use cases which use the camera-based solutions. So now, as we are moving towards more and more of the camera-based solutions, so what it is that would be requiring an intelligent network, and if I may say, that's the 5G. So many of the continents still do not have 5G, and India as such, we still do not have. But it is 4G LTE to predominantly 5G, because 5G is actually a transition, right? It's a transformational journey. It doesn't end or stop. So it has just started. So what it is that would require this kind of intelligent network, where we talk about loads of bandwidth, the 20 Gbps bandwidths, which 3 Gbps is playing, 1 millisecond latency, and kind of likes, right? So there is a huge bandwidth requirement as we move towards more of the quality video, right? HD quality, FHD quality. Now we are talking about 8K or the 4K videos. This kind of video streaming would definitely require a very high bandwidth, which is probably not being the forte of 4G LTE or the Wi-Fi's of the world. And more so, if we are talking only about 1 or 2 devices, it will going to cater. But where we are telling that the whole enterprise situation needs to be, or the whole smart city, or as Hafsa was mentioning, the naked road constructions of the world. So that kind of humongous amount of the data which is getting generated through all the devices put together would definitely require a intelligent network, and that intelligent network is 5G. The performance perspective, the quality aspect. Now there is another aspect which is driver for using intelligent network, and that's the requirement coming from every data needs to be inferenced on real time. I need to see what is happening just now at this point in time. That's what the requirement which is coming out from across industry segments. They would like to see how the digital safety, how the worker who is going to there in the field is operating the valve. They would like to see that if there is a lone worker, or if there is a fall happening, or if there is a drone capturing the surveillance aspect, all those data which is getting generated needs to be inferenced at real time. And that's where the beauty of MEC, the multi-access edge compute, comes into picture, which is very close to our on-prem setup. That's where the more importance of MEC comes into picture. So we may say that how it is getting benefited, how MEC is getting benefited. We need to see how this whole latency picture comes into picture, how the privacy and the cost aspect needs to be taken care of. As we were discussing sometimes back, that the whole data, if it needs to be processed over cloud, there is not only the backhaul requirement, which increases tremendously, but there is a cost also associated with it. That backhaul can be anything. It can be satellite or over microwave or over fiber. So that backhaul requirement increases drastically. And if we are in a condition where we can process this kind of data over on-prem, over MEC, and maybe 60 to 70% of the data is getting processed onto the on-prem, and rest data is getting transferred to cloud. So that kind of architecture where there is a breakout happening in MEC, and then the rest is being transferred over cloud for your monitoring aspect or for your historization aspect, those can be thought of where the cost will go down, because implementing 5G is very capex intensive, right? We need to see that how we get the ROI on the longer run. And that's how these kind of architecture where there is 60 to 70% of the data which is residing on site, where the security aspect or the privacy aspect is also being taken care of, and we need not worry so much that my data is moving out of my premises. And then the processing also happens on the near real time. Okay, so this kind of scenarios are definitely, we need to shift the intelligence which we are seeing, that needs to be shifted to the edge. Okay, and that's where this kind of three-tier architecture is being worked on. And we from TechM, we heavily propound on this kind of architecture where there is an enterprise edge and the infrastructure services along with all the breakouts and the content caching happening on the MEC node, and rest all our ERPs and the PLMs of the world, the enterprise analytics is being taken care of over the cloud. And this way, through SD-WAN, the software-defined WAN network, we can connect the multi-sites, because enterprise is having a foothold across globe, right? So this kind of architecture would definitely going to be in a longer run, which will going to help the whole of the organization. And that's where the beauty of MEC and 5G, the intelligent network and video analytics, given all the use cases which are into the foray, would bring the total ROI and the benefit which the end consumers are looking forward to. And that's what the bottom line is, Richard.
Thank you kindly, Kamkam. Indeed, you may thank you. Stop sharing now. Yeah, looking at this is I think about data proximity, and I think Danny, you got some thoughts on this.
I think Richard, all of the use cases that have been discussed today, Neil mentioned quite a few in terms of the industries that we're moving into. The reality is, it is now about where do we process the compute. So the proximity is key, and it can happen at the edge. Of course, it can happen on the device, but there's a great opportunity now with MEC to really lower the cost of a device. So a great example, we all are familiar with the cost of an Oculus Rift headset. You know, our kids probably want one for Christmas. It's $500. You know, the reason for that, all of the compute is happening on the device. The 5G and the MEC gives us the opportunity to take that away from the device and move that the network or to, you know, to the premises if it's a factory of the future, as Neil described. You know, so it's the compute and where do we process the compute, but by taking it from the device and to the edge of the network or to the location itself, actually what we do now is we enable mass adoption of these applications because we can lower the overall cost of adoption. You know, and especially when we consider about some things like in healthcare, you know, how can we leverage for telemedicine or for care in the community, care homes, how can we use video analytics devices or mixed reality, virtual reality devices to provide healthcare, leveraging a public 5G network, and therefore it doesn't require big infrastructure payments from the business to take advantage of that and lower the cost of adoption of these technologies. All of that is only possible because the proximity of the data. Where is the data and where is that being performed? And of course, Paul also talked about it. Let's do it in the car. We don't need to do it, you know, maybe at the edge of the network. It could be mobile. And in which case then and you want that to happen, right? In autonomous vehicles, we don't want the information to be processed. Is that a human crossing the road? Is that a cyclist in front of me? We don't want to do a round trip to AWS in the cloud or to Alibaba, Alibaba in China. We want to be making that decision in real time. So how do we do that? We do it at the edge. So proximity is king when we come to video analytics and getting a real return on the investment, but it's also king in terms of reducing the cost of adoption over time, our ability to move that data and process it closer to the edge and off of the device. And that's quite important. It's going not just from the cloud, but to the edge, but also from the device to the edge. That creates this great adoption of application use cases that can really see us explode in terms of where we can bring transformation.
Thanks. Yeah, we had a question in from Dean, a good one. I mean, many of the device cameras and whatever, more and more of those are looking to put more and more compute onto the device to sort of pre-process before they send the data out. So there is that trend. So Danny, others, please comment. Do you see that as something that's antagonistic? Is this something they resorted to because we haven't had the capabilities that MEC produces? Or are they both going to blossom and it's a horses for courses sort of thing?
Yeah, my view at this stage, Richard, would be that it's complementary. It's about processing the edge compute. So these can start to deliver the transformative outcomes. We haven't fully, and just in the same way, there's lots of different ways we can deliver 5G networks. So private networks, hybrid networks, dedicated networks, in-building 5G schemes. So there's lots of different ways you can skin a cat with the 5G architecture. The same is true of the edge compute. So it's on the device, it's at the edge of the network, it's on the premise, and it comes in different form factors. The application and the outcome, so what are we trying to achieve and how are we trying to achieve it, determines the best route to that. So from my perspective, all of these are complementary in terms of delivering true automation and true transformation. The example that Neil gave around, Rolls-Royce building the engines and having video analytics right across the factory plant, that makes a lot of sense for that to happen at the plant and not on the cameras. Those cameras don't need to be expensive cameras with edge compute running on them when we can run that edge compute in the corner of the factory. That's, so lots of the cameras talking to the compute at the edge of the factory. However, if we have a use case, maybe Paul's in a city sphere where actually a lot of the compute happens dispersed across the city, then it makes a lot of sense to put the compute in the camera, or maybe in a distributed MEC environment where we can deploy distributed MEC. So AWS, they've got their capability wavelength. We're bringing that to the UK. That's the distributed MEC approach. So I think it's horses for courses is the answer, and depending on the outcome and depending on the way in which we wish to deploy the technology, will it depend how we skin the cat.
Thank you, sir.
Yeah, I kind of agree with that, Danny. I think we end up with edge computing at every layer, because if we take the kind of transport and autonomous vehicles kind of example, in that we know that we want to be able to make decisions at a car level. but we know that we want to be able to make decisions at a road level. So it becomes, how does a car communicate to the road? And the road needs the ability to make those decisions. So you have edge on the road. We know that those roads need to communicate to one another. So actually, how do you have edge computing within regions or nationally to say, well, if we reconfigure the road environment, where do we never get rid of traffic, we just shift it to somewhere else. So what will the impact of that be? And I think you can kind of see that almost edge computing has to happen at each layer where you want a decision to happen. So you can kind of see where you would have edge computing in a car, edge computing on a road or on a street, and then edge computing in a network level. So I think they are really complementary, because in reality, we can have the most intelligent roads in the world, but if the cars can't keep up with that and make decisions based on that information, you never really get the true benefit. So I think it is that kind of horses for courses, and actually layering some of these solutions and saying, right, well, we'll do some compute at this level because that's the right place for that. But actually there's some compute that's the next level up. And then there's some that we just send off for more advanced analytics in the cloud as well. And kind of all of those things blend together to give you the perfect solution.
Good example, Paul.
Oh, thank you kindly. Righto, break things up a bit. We're going to move on to sort of other regulatory issues and what have you. But first, Aparna, a poll. Okay, indeed. Please let us know which of these amongst the audience do you understand most, are you most comfortable with? Okay, gone sort of thing. I think we'll have this up for about 30 seconds or thereabouts. And so much for democracy. Hosts and panelists don't get a vote on that one. Thanks indeed. The committee will take that one. Oh, there we go. Okay, right. Thanks. That's helpful. So we're all 5G experts. We know a little bit about MEC, and the video analytics bit. Never fear, we've got some of that coming up. But first, Hafsa. Okay, so we're taking all these high definition pictures of people's faces and things like this. There must be regulatory aspects to running these systems. Could you give us an indication of some of the implications there?
Yeah, sure. So I think the biggest sort of aspect that comes to mind when talking about 5G and also video analytics is sort of the citizens' hesitancy due to privacy and the regulations that exist around there. So I think there's a part about understanding that what actually edge computing allows us to do is to work within the realms of existing regulation where it impacts the privacy of individuals. So it's possible for a camera to be able to process all of the information on edge and only transfer the data that pertains to, you know, an incident or whatever the use case is, or irregular behavior, so that actually the privacy of the masses is not compromised. We're seeing solutions come up which actually, you know, anonymize the data before it leaves that device, so before it gets onto the cloud. So it's actually bypassing a lot of the typical regulatory but also consumer hesitations that we would see. The other area about regulations worth talking about, so from a more local council and cities perspective as well, is working with them. I mean, it's very similar to the poll that we just conducted, in the sense that there is different levels of maturity depending on where you go and who you talk to. So you have some cities, not just talking about the UK, but generally globally, developed nations, we have cities who really understand 5G, they understand use cases, and, you know, like Paul mentioned, like going out there, trialing things, seeing how it's going to benefit them and the citizens. At the same time, we've got some councils and cities who are not actually sure what 5G does for them. What they get is a lot of people knocking on their doors, asking for planning permissions for things that they don't fully understand. So it's all well and good that there's regulations, and a lot of work is being done by the UK government on making sure that we have appropriate regulations for innovation, but there is inconsistency in how it's applied and understood at the local level. As Denny's been mentioning, this uh, this innovation needs to be led by the use case. It needs to be led by the need. And if the end consumer, end business doesn't fully understand that, then this can be quite difficult to actually achieve. So it's one of the barriers that we keep seeing sort of coming up. So there's number one, understanding of 5G, understanding of what MEC is, understanding of video analytics and how that can help. Then going on to actually what the regulations are and how they apply to each council. So whether that's planning permission. I mean, and not so long ago, we saw news about councils taking too long to approve planning permissions. That's a constant thing we hear about. And every time it comes to regulation and everything new, there's always a danger of analysis paralysis, where if something new, you don't fully understand it, so you go into analyzing loads and actually miss the opportunities that some of these innovations present. So I think yeah, actually, I think it all kind of drills back down to that there's a lack of consistent understanding of the technology itself, but also the regulations that are in place to promote it.
Thanks. Yeah, indeed. I mean, I think it's a given that we need more stuff, furniture, kit for 5G. And this means a lot of locations, sites are required by infrastructure providers, operators to do this. And there isn't universal understanding, peace and harmony around that process. I've been quite impressed with the work that's been primarily driven out of West Midlands Combined Authority and the DCMS barrier busters around things like EC code valuations and how to take some of the pain out of that, and also the strategic mapping of location for potentially assets as you digitalize going forward. Paul, you must have plenty of experience of smart cities context of some of these regulatory issues. Can you share some learnings, both positive, negative, maybe?
Yeah. So I think in terms of the deployment of infrastructure, it benefits me very well. That's how I make a living. So we are starting to see councils employing people who are actively there to engage with the market, and kind of my job is to go to the market and get more people to deploy more in North Tyneside and to deploy faster and better. So we are starting to see changes in that, and I think we are starting to see changes in attitudes, and kind of, as with many things, the COVID crisis has helped that in terms of reframing the importance of digital infrastructure. So it's no longer just seen as, oh, well, people are digging up the roads or putting masts up. And I think that's really helped and changed the attitudes. In terms of the regulatory issues, I think, like Hafsa said, there's some things that edge computing can help with. I think the other things that we've done is we've worked really closely with the university and with people like MHCLG, making sure that we do really robust ethical assessments on anything that we do. So kind of we rule out and say we're not going to do as many things as we say we are going to do, because everything's technically possible now. The other thing that we did do really early on was have this ethos of, we're going to work out in the open and we're going to be really transparent about what we do. And part of that, so people can see what we're doing, but part of that is actually all of our benefit really comes from citizen behavior change and people making more informed decisions. So we always said from the start, we want to push as much information out to the citizen as we can. So making sure they know exactly what we do. So all of our CCTV cameras, you can go on a website and you can look at every 5 minutes, it takes a snapshot, and those are open source for anyone to use. So all of the public can actually see all of the things that we are using as well. So there's this real trust and transparency around kind of how does a city not look like a big brother when that's inherently the kind of what people think of when they think of cameras? And like I say, our approach has just been to be really open and honest and be really visible and be really encouraging for people to interact with the data themselves, but making sure that that's backed up by, again, if you look on the How Busy Is Toon website, you'll see a really robust privacy statement. So exactly what we're doing with the data, how we're processing it, and how long we will keep it, and ethical assessments around what we will do and what we won't, and what things we are happy to do. So we'll never track people, we just count people. We never kind of look at people's faces and do any analysis on that. We don't really do routes of, like, we'll never track where you've been in a city. We might track the direction that you're walking in, so we can see how many people are going up a street and how many people are going down a street. But we never kind of track individuals around. So I think it's just having those kind of core principles that you then stick to, because there's always oh, but it can do this. We could see who's wearing a mask and we could police mask usage. And those are things that we've just never wanted to do and have no desire to do. So it's about that being brave enough to say, like, the technology can do it, but we don't want to do that. And these are why we don't want to do those things.
Sound, yeah. Just because you can doesn't mean to say you should.
Yeah.
I think there. Okay. Any other observations from the other panelists on regulatory issues before we move on to the, if you will, the grand finale, which is a sort of a showcase of an exemplar? Nope. Okay. Without further ado, then let's see some of this stuff in action. Alexander, good to see you turning your video on. So please tell me what Telefonica and DeepSight have been doing in this space.
Yes, actually, we are all collaborating in a research lab in Madrid named Photonic. So in there we have a 5G SA core network, and we have been working on use cases where we are doing a tight integration between the edge and the 5G SA core network. So I think here we see some of the slides. So I don't know if we see the partners, so Photonic, the labs. So I'll let my colleagues from DeepSight do a brief introduction first.
Yeah, sure, Alex. Thanks, Richard. I think the first slide, what you're seeing is this use case. Video analytics is something we all know. It's quite high bandwidth is needed. Latency is not at all compromised because it has to be in high speed. And till 4G, like we have been doing a lot of video analytics from last 2 years, but on the 4G network, there's always been certain challenges, right? So IoT has taken a huge, benefit from 4G, whereas video analytics is in the nascent stage of going into cloud or going into edge. It's becoming to more reality now. In this regards, Alex mentioned, in partnership with Photonic, Telefonica, Ericsson, etc. We made this use case to test and understand, what is the threshold, what can happen when videos are sent over 5G and at certain conditions and certain use cases. So this was happened in Spain lab, and for the duration of around 3 months, thanks to our partners and especially Photonic, which helped us to enable this. So I think we will talk about this use case in more detail. I think Nishant, can you please provide a flow of this use case, and then I think Alex and Jorge, please take over for the explanation. Any questions, please do ask us. Yeah, thanks.
Thank you, Rakesh. So before moving to the actual use case, I just want to tell you some common thing. First of all, we have discussed a lot about the advantage of MEC, advantage of 5G, the lower latency, higher bandwidth, more secured communication. But I am just going to talk about the advantages of application which is going to consume this much high bandwidth and lower latency communications. So the application required to that, like Kumskum has touched some point where there should be a distributed approach in terms of deploying the main high computation part at the network edge, and whatever the saving part that could be on the cloud side and these things. So we have built in this application where it has power to consume thousands of camera in the real time and add n number of feature in real time to process the things and raise the alerts actually. So moving to the next, the actual use case which we have done. So this is in collaboration with Telefonica as an operator, Ericsson as a core network provider, and Capgemini as a MEC provider. We have onboarded our application on the network multi-access access edge computing platform, where all the data is like the data from the actual CCTV camera is coming over the 5G router via on the tower side, and there we have onboarded our application, and we have demanded the quality of service requirement on the MEC, and MEC is talking to the 5G network in order to provide those quality of service to our application, and then based on that we use alerts. So important point here is that because the edge multi-access edge computing is accessible because it's more secure communication. So primarily it should be accessed via the operator zone. The operator customers can access this particular zone. So those things are completely they are getting it actually. So this is what. So on the top of it, this is what we have done it. As soon as we detect something, we raise alerts and we send it to the common cloud server. So this is how it is done. This particular use case. So the facial recognition, human intrusion part is being done on this. So over to I think the next slide.
Over to Alex and Jorge, please.
Yeah, Alex and first.
Yeah. So sorry, in Telefonica we are keen to explore with the rest of the industry this concept of making more than distribution of data centers for the edge. So actually, with a lot of industry players, we are collaborating in the GSMA for this operator platform concept. Jorge is going to describe to you. He's the chief architect for all this concept in terms of platform and the trial. But in a nutshell, as an introduction, we really want to make full usage of the network for the edge. And for that, we need somehow to integrate what is the edge as a platform layer with the rest of the network. And we have been pushing for this in the standards. There are many players involved in the GSMA in this definition. And then we took this reference kind of concept and tried to build it in the 5tonic lab for the deep site use case. So Jorge, maybe you want to give some technical view on the concept.
Yeah, thank you, Alex. So starting with this initiative in GSMA, as Alex mentioned, Operator Platform Group is a different network providers, network operators group, joined by more than 35 operators, more than 20 providers that wanted to enhance or to provide a definition of the end-to-end of an edge delivery service. Because at the end, we don't want to have only this distributed cloud, as Alex was mentioning, but we also want to take advantage of the different capabilities that our network provides. That is why we have this complete architecture here, starting with the application providers, the developers that can deploy the application, can deploy and can define the different criteria that this application needs to follow in the architecture through the northbound interface, the interface connecting the developers. And then we have the different interfaces connecting to the resources. Of course, we have an interface connecting to the cloud resources because we are going to deploy application in the cloud environments that we have, but we also want to engage with the network. We also want to request for different capabilities on the network, take advantage of the authentication that they do with the devices, take advantage of the quality of service, the reliability. We need to have this kind of different interfaces with the network also, with the 5G core in this case, as we will see later, but with any other network. We also proposed to have a east-westbound interface, a federation interface that allows at the end many operators to join the force together and allow one developer to deploy one and have the application deployed all over the world, just away from the country that he's connected to the proper operator, to all the operators that are part of this country, and also abroad, of course. This is what we call the roaming of the applications, so that the applications are deployed everywhere, just deploying once. but we also want to enable the roaming of the users. The same as we have a roaming for the voice, we can, or we want also to have the roaming for the edge service. And finally, we have a specific interface so that the final devices, the agents that are on your mobile device that wants to connect to a edge application, can communicate with this platform, can request the service, can authenticate also itself, and we can also manage the mobility of these devices along the country and abroad also. So if we go to the next slide, please, Nishant. Yeah, here we just want to remark what we have deployed for this specific proof of concept with deep-side video processing applications. Just starting with the pieces, we have the MEC platform from Capgemini, from Altran, managing the end-to-end service, as we have presented before in this operator platform, following the standard, of course. We have the Ericsson 5G core network, managing the connection of the devices. And we have these devices, this surveillance camera, and the edge video processing application deployed on the edge. So starting with the basic service that everybody understands at the edge, which is deploying the application close together with the devices. We do this placing the servers close together with the UPF, which is the 5G network element, managing the connection of the device. This is the shortest path that we can take for the connection of the device. But we also wanted to make more things. We want to have a complete edge service. That is why we have these additional interfaces, starting, for instance, with the UNI, the connection from the cameras to the MEC platform, that can manage the connection, can allow this camera to discover which servers they need to connect to. But we also have additional interfaces, starting again with the normal interface, so that the developers can easily, in this case, DeepSight, can easily deploy the application. And we also have this advanced interface network connection to the NEF. The NEF is the gateway of the 5G core network, the standard one, that provide access to external parties to request capabilities to the 5G network core, so that we can securely provide these capabilities from the operator to external parties that want to have these capabilities. In this case, we have tested some of them. Of course, there are a lot of much more capabilities, but we have focused on providing different information about the devices. For instance, the location. We can provide a trusted location of the device information to this external application. We have also tested the guaranteed quality of service, so that in this case, DeepSight can request so that the connection of this surveillance camera are always treated in the best possible fashion, so that independently on the situation of the network, independently that the network, the radio core or the radio network is overloaded, the connection of these cameras for this application is always treated with the most optimal quality of service. We also have some capabilities for modifying the charging policies that we have on the network, so that, for instance, in this case, DeepSight can charge the connection of these devices instead of the proper owner of the connection of these devices. And finally, we have a much more advanced use case, which is the optimization of the network routing of this edge application, so that we can predict the movement in case this camera has mobility. We can ensure that the traffic is always routed in the most optimal way, independently of the location of the application. When we need to change the link just because it is overloaded or whatever, we can always optimize this routing of the applications. So our intention with this is just remark which are the capabilities of the network that we can provide to the edge service, so that it is not only an edge service. It is not only a distributed cloud service. This is a complete telco edge service that can evolve to something that the application may consume in this feature.
So I think here the main comment is that the 5G network has really been built for edge. Okay, all these capabilities are standard capabilities that all operators can look at and deploy. And it has really been so to do this tight integration and enhance the application experience with the edge. So that's the great thing about the 5G network.
So here one thing I want to add. Here, along with the alert, the intelligent DeepSight is going to send the intelligent alert by taking the information of 5G, like the location information of the mobility, because it's a mobility, the camera is moving, so mobility information of that particular cell. So along with the alert, we can send the mobility information on which tower it is. So it is also has a tight packed integration with this, whatever the cell information is there, along with the alerts and what movement is there. So this is what we have achieved together.
Yeah, I mean, the 5G core network is totally API based. So asking for this information is just doing this API integration between the gateway of the core network and the application. And its location, but not much more information could even be been requested and bound to the application. So again, it's quite a useful capability of the 5G core that can enhance the edge experience.
Thank you kindly. Indeed, for me, that's what 5G, AI, IoT, the fusion of coming together is all about. It's surfacing those new capabilities. Indeed, thanks very much for that run through of the 5-tonic MEC standalone integration. I look forward to seeing very similar proposals in the smart networks and services calls that are coming up later in the year. Indeed, thanks very much. Okay, if you could stop sharing now, we're coming into the I think we're in the final 10 minutes of. So thanks. I mean, the takeaway I get from this is these are powerful capabilities that are being surfaced. There is almost unlimited flexibility in the way that you can architect it. So to pick up again on a question that Dean raised right at the start, if it's so brilliant, why aren't we falling over it all the time? Could I ask you briefly, you know, what's the easiest thing to do here? Where have you had the most success, and what's the hard thing? What are the things that can push this forward? What's the one thing that's holding it back? In no particular order. On your marks, get set, go.
Maybe if I just come in, Richard. I mean, no one. I've said this in many other things. No one ever comes into one of our stores and say, "Hey, we want edge compute," right? It should be invisible. If you watch The Mandalorian, on Disney Plus, on BT or EE, you were using edge compute to watch it. It's there, and we're delivering content today. If you are if you're playing a number of video games right now, both streamed and direct, you're using edge compute. In many cases, if you're using a mobile network, you're using edge compute. So I think you know, it is out there. I think where the lag is, and I think definitely COVID's impacted this, is getting the developer community up and running, and their ability to understand the benefits and opportunities from this. But I'm absolutely convinced that's just a timing issue, and it will come.
Yeah, I'd agree with Neil there. I think we probably are falling over it all day, every day, without realizing those are specific edge compute examples. Like you say, every time we watch Netflix, everyone's watching Tiger King at the start of lockdown. So that's being delivered from a local BT exchange or data center rather than going out to Netflix. I think in terms of cities and applications that we see, again, it's kind of always been there. I think we're seeing the maturity increase. So we are now working with better quality imagery so we can do more analysis on it. The compute and level of compute that we can do at the edge practically is now far in advance of what it was. So again, that's kind of moved us on a little bit. I think, to answer your other question, the technology is normally the easy part. I mean, I know everyone's talked about some really complex software orchestration of networks, but that's normally the easy part. And the kind of how as businesses and how as industries we embrace that and embed it and change our processes and systems and way of working is normally the hard part. So we've been able to deliver a lot of these things, and kind of every one of the telcos who are on the call will straight away say, well, we can deliver a lot of this service over an existing 4G network. And we are only just starting to see the kind of public acceptance, or even within cities and councils, we are only starting to embrace smart cities and the use of data to do real-time changes on cities. And I think as things progress, you'll start to see certainly things that can only be done by 5G. But I think we're just almost a little bit on that adoption curve still, and we will only see that to go up as people become more and more comfortable with the technology and basing their decisions on real-time data and things like that?
So I think operators should play a big role because operator is directly connected to the consumers. So in order to realize at the consumer level buying such kind of applications, operator needs to package back to back with the MEC application provider who is onboarding their solution on MEC. There are a lot of MEC companies are coming. AWS has a weblet platform. So operator is going to play a big role in order to connect to realize this thing to the consumer level, because back-to-back partnership should be there and package, and ultimately video analytic solution should be delivered to the customer actually on the MEC zone. That is what I feel actually.
Richard, I'll bring it back to the point I've made continuously, which is it all comes back to that. What is the outcome? And even to, it doesn't matter if it's an industry outcome or a consumer outcome. And Daniil's point, it's build it and they will come. We're in a chicken and egg scenario at the minute. The developer community, we really need them on board to say, okay, so I've got the latency and capacity benefit with 5G, and actually edge compute is something that I can take advantage of. And therefore I'll begin to build these applications that can consume that. And when they do that, it will be a time when we can walk into football stadiums and, and leverage our phones to use some great Mac edge compute to get real-time in-game analytics, or, the use cases start to really explode. As consumers, we probably don't realize we're benefiting. That's the first time I'm hearing from Neil that we're using Edge for The Mandalorian. I've watched it all back to back. So there, it's a great, I didn't know it was invisible, but actually what we'll see is much more adoption when the developer community comes on board and starts taking advantage of the capability the network operators have had to invest a lot of money into. So we're at this early adoption stage, and it will be great to see that on the journey.
Indeed, yeah, we sort of focused on the sort of video and AI, but yeah, content distribution. There was a beautiful example, a football fan with massively impaired sight, it's fair to say, but by use of sort of UHD camera mech and sort of blowing up a very small number of pixels large, he was able to effectively see a football game for the first time in his life. And it was literally one of those scales falling from his eyes. And I thought it's kind of trivial, but a brilliant example of what this tech can do that is meaningful in a human context. Rakesh, sir, you have your hand up.
Yeah, Joe. So Richard, there are a couple of questions. I don't know if we are looking at that. The first question is if mobile edge computing is such a great idea, why haven't we had fixed edge computing for 10 plus years? Given most enterprise use cases today, camera screens, automation systems are wired. So I think this was one of the question that was, Dean has mentioned. So just to add, I would request others to please add your views. I think, certain technologies, like every technology needs supporting layers, like when we talk about IoT, we wanted, more better networks. We wanted, like when it was 3G, we were talking about just, mobile videos. It was, I think, way back in my, job in Ericsson, we were talking about 3G for mobile videos, right? And that needed a lot of bandwidth. I'm talking about 2006 and 7. But I think it's not about, I just found, I don't know how many have heard about IMS, IP multimedia subsystem, which was a great thing for IoT, but it never took off. So in the same way, I think for this question, the mobile edge computing, even if it is there or it will be there, it needs many other supporting components. Like in this case, if there's no great applications, like I think rightly said by Neil and Paul, Danny, that I don't know what I'm using as an end customer. I don't know what I'm using. I'm just liking to have this great speed, great stuff. But end of the day, as a technology companies like telecom companies, infrastructure companies, or AI companies like us, we need to come together and create these applications that can work anywhere, right? So that's, I would say, is happening now. And that's why I think mobile edge computing is gradually going to be picking up much bigger. I think if panel wants to add, please do add.
I think was also really expensive in the past. Like,
Yeah, I think
we've
that's
kind of seen the kind of single chips and neural engines has put way more compute power in smaller devices that in the past we would have used whole racks of servers to use. I think equally, those things always relied on a lot of backhaul, and I think the fabric of networks around places is fundamentally changing in the UK right now. Like, again, if you'd asked me 2 years ago, as a local authority, would I be looking at putting a point of presence in a national internet exchange? Absolutely not. But that's something that we're actively looking at doing now, so that we know that there's a huge influx of fiber networks and 5G networks being built. And actually, can we move our services closer to them by using the same types of edge concepts? And I think we are just seeing kind of a few different things in the industry shift to just make some of them really kind of tangible business cases stack up that they never have done in the past, or certainly that's kind of where I find it.
Thank you all. Some fine observations there, some great wisdom, some good case studies, some good examples. We are, I regret to say, out of time. So may I thank all the panelists and presenters for sharing their knowledge. Can I thank all of you for coming along and learning and participating in this. I feel sure that Aurora will be following up with some sort of feedback survey, and given the subject and where we are in the evolution and deployment of this, I'm sure we'll be back before long to consider some of the other transformational aspects of 5G and associated technologies. Thanks very much for coming. See you soon.
So much. Thanks, Richard.
Thank you.
Thanks. Bye.
Thank you.